All right, so in 5, we're going to talk about area and how it also relates to probability. So it says determine the area of each unshaded region. Okay, so to find the first one here, I would have to find the full shape, which is a rectangle. All right, so if I have rectangle and a triangle, so rectangle formula for area is base times height. Okay, triangle is 1/2 base times height. So if I want the unshaded, I have to do my full shape. So 9 times 6, which is 54. And I need to take away the triangle. So the triangle is 1/2 times the base of the triangle is 6. The height of that triangle is 9. So that's 27. So if I just want the area of the unshaded region, I do 54 minus 27. And I get 27 centimeters squared. Okay, number 2, I have to do, looks like a square, so base times height, so 10 times 10, which is 100. And this time I want to take away a circle. So my circle area equation is pi r squared. Well, if all the way across is 10, the radius then is cut in half, so it's going to be 5. So I'm going to take away pi times 5 squared. So I'm actually going to use the pi button. And that is 78.5. So 100 minus 78.5, 21.5 feet squared. Okay, number 3, you could do it 2 different ways. Okay, I could take my total area, so pi r squared, and then I can times it by how much I actually want, which is 3/4 of it. The other way you could do it is you could divide it by 4 and subtract that answer from your total, because then you would be subtracting that 1/4 away, which is what a lot of you guys do. Okay, if I just want 3/4 of my figure, I could just type it all in at once here. So pi times 2 squared times 3/4. So 9.4 inches squared. Okay, so then how does this relate to probability? Okay, so we're going to skip this, make a deal, and we're going to go straight into it here. So it says the class is hosting a dart competition to raise money. 3 different designs are under consideration are shown. All of the dartboards are squares that measure 50 by 50, so we're going to have to use that in a little bit. For this situation, you have to assume that a dart is thrown randomly at a dartboard, and the dart will land somewhere on the dartboard. Okay, so which dartboard will give the player the greatest chance of hitting a shaded section? So I want you to decide which one do you think is going to give me the best probability of hitting this shaded section. It says you can use what you know about probability to determine the chance a person has of hitting a shaded section on a dartboard. What value would you use to represent the number of all possible outcomes? Well, all possible outcomes is just me hitting the board. Okay, so my entire shape is all my possible outcomes. So in this situation, it's everything in my rectangle, or in my square. Everything in my square is all my possible outcomes. The ones I want, my desired ones, is all of my shaded. That says shaded, sorry. My shaded shapes. Okay, so it says, we're going to skip Devin's response and go into this. So it says determine the probability that a dart lands in a shaded section of each dartboard. Remember, probability is a fraction. Okay, so when we represent these, we have our desired, or what we are choosing, so my shaded section in this one, over my total shape. So it's still what we're choosing over our total, like we do every single time, but now we're just using area equations. Well, my desired shape in this one is my circle, because I want to hit inside this circle. It said earlier that it was a 50 by 50. So then the radius is 25. So to find him, I'm going to do pi r squared as my desired over my total shape is a square, so 50 by 50. So I'm going to type in pi r squared 1963.5 all over 50 times 50, which is 2,500. Okay, so if I do 1963.5 divided by 2,500, I have a 78.5% chance of hitting the big bullseye, the shaded section in it. Okay, so my next one, it's still 50 by 50. So my total bottom is still going to be the same, that 2,500 for both of these, because the total shape does not change. Okay, so if all the way across is 50, that means halfway is 25, which means the radius is half of that, which is 12.5. So I've got pi times 12.5 squared, and then there are 4 of those circles, so I'm just going to times them by 4 to get all 4 shaded sections. So pi times 12.5 squared times 4, 1963.5. Okay, so if I divide them here, we get 78.5%. Okay, so right now we have the exact same percentage to hit shaded sections in this one. Okay, this one is a 50 by 50 again. So that's how we have the 2,500. Now we're doing triangles. So I know it's 1/2 base times height. So if all the way across is 50, then part of it is 25, which means that's 25. So I know I've got 1/2 times 25 times 25. Now, in the directions here, it said that they're all congruent. So how many of those do I have? 1, 2, 3, 4, 5, 6. So 1/2 times 25 times 25 times 6, 1875. So my percentage then, 75%. So that one is actually going to be the hardest one. So it says, which dartboard should the class use to make the competition the most difficult? Well, this one has the smallest percentage of me actually hitting shaded space. So tricky triangle, because it has the smallest percentage of outcome, smallest percent of space to hit. Okay, so geometric probability is just a probability that involves a geometric measure such as length, area, volume, and so on. Okay, so we're going to skip this one here. So as exploring expected value, you are a contestant on a game show. In the first round, the host gives you $200. You can keep the money or give the money back and spin again. All the sections on the wheel are equal in size. Would you choose to keep the 200 or spin the wheel? So decide what you would like to do. It says if you spin the wheel, what is the probability that you will win each amount? So how many hundreds are there? 1, 2, 3 out of how many lines? So that's 3 out of 1, 2, 3, 4, 5, 6, 7, 8. So 3 out of 8. So all these guys are going to be 8s. Okay, how many 200s? 1, 2. How many 300s? 1. 400s is 1. And 500s is 1. So it says if you spin the wheel, how often would you expect to win each amount? Well, 3 out of my 8. So 3 out of 8 times that I spin. 2 out of 8 times. This is 1 out of 8 for these because they're all the same. Okay, so it says, let's calculate the expected value, the value that you would expect if you spun again. Multiply each amount by the probability of winning. So if I go back, my 100 was 3/8. So 100 times 3/8. Then my 200 is going to be times 2/8, or 1/4. Okay, my 300, 400, 500 were all 1/8. Squeezing it in there. So 100 times 3/8, $37.50. 200 times 2/8 is $50. 300 times 1/8, $37.50. 400 times 3/8 is 400 times 1/8 is 50. And then 500 times 1/8, 62.50. Okay, calculate the sum of the values. So sum means I add them. So I'm going to go ahead and add all those guys. And I get $237.50. So what we just found is that on average, if you would spin again, you would get $237.50. So then it says, based on the expected value, so the value you would expect if you rolled again or spun again, should you keep the 200 or spin again? Well, I would spin again because my expected value, if I kept spinning, is actually greater than what I originally started with. I just gained $37.50. Okay, so the step 1 is find probability or decimal probability. Okay, then step 2 is multiply. Step 3 is to add or subtract if you are losing. the money to find your expected value. Okay, so it says calculate the expected value for one spin on the wheel. So first, we find the probability or the percentage of each, and we multiply them. So 100 appears 2 times out of 2, 3, 4, 5, 6, 7, 8. Okay, 200 appears one time. 300 appears one time. 400 appears one time. 500 appears one time. 600 and 700 both appear one time. Oops, not equal signs, I want multiplication. We multiply by that percentage or that decimal that we have. Okay, and then once we multiply all them, we add them. And we're adding because we are gaining money each time. If it would have said we lost money, we would subtract. So 25, 25, 37.50, 50, 62.50, 75, 87.50. So now we add them to figure out my expected value if I were to keep spinning. Okay, so in the scenario, which I forgot to read, in the second round of the game, you're offered 300. You get to give the 300 back or choose to spin again. Okay, so now my total is $362.50. So I would spin again because I just gained $62 more than what I had originally.